Hello everybody. In this video we're going to be looking at the Mercury SR2's sequencer programming. We're going to take a deep dive look into the programming, look at all the options and set up a few examples. So speaking of examples, I've got a simple setup here with a couple of servos. We've got a nose wheel. So this servo here is our nose wheel steering indication. So nothing really to do with the retracts, it's just basically our nose wheel steering. I've also set it up with a gyro. So the reason being is later on, one of the features inside the Mercury SR2 sequencer options is to lock the nose wheel to a particular orientation before the wheel is retracted. So in a lot of aircraft, we usually may want the wheel, say, pointing forwards when we hit the retract switch to ensure that the wheel doesn't foul anything inside the retract bay once the retract is actually inside the aircraft. In some cases, you may not want the wheel pointing straight ahead. You might want it offset. You might have some oddball clearance issue, and the wheel might have to be offset, say, to the right or the left when it's retracting. And we can set that up in the Mercury. So as soon as you hit the retract switch, so you take off from the ground, you rotate, you get airborne. As soon as you hit the retract switch, the Mercury will offset the servo if need be and hold it there as the wheel retracts. The wheel retracts, stays in that lock position, and then when the retract's deployed, it will only release the wheel, convert it back to normal steering once the retract's fully deployed. So that's a really handy feature, and I'll show you how to program that up a little bit later. So that's why I included that servo. And the reason I included the gyro, so I've just got a gyro, I've assigned one of the rudder functions to control just the nose wheel. Is basically to also show you that the gyro function is also disabled as well once we hit the retract switch. Okay, now moving along, I've got a little servo here that's labeled gear. So this servo here is going to simulate our actual gear function. So typically in a jet you may have air retracts or air operated retracts. So this servo is going to be receiving the signal that would normally go to the valve for your retracts. Or if you've got, say, some electron retracts which are electrically operated, again this servo is just going to be an indicator for us as to what the signal's doing in regards to whether it's gear up or gear down. So that'll be fairly easy to keep an eye on. So again, this is our gear signal servo or indicator, and this is our nose wheel steering servo. So don't confuse the two. Now, on a lot of aircraft we have some gear doors as well. So we've got one here for the nose. So I've just labelled this door F for front. So this is going to be our door for our front nose wheel. And I've also got two rear doors as well. I've got a left and a right. So this will be the left wing, RL, and double R for rear right. So they'll just basically give us an indication of what the rear door's doing. So the sequencer controls the rear doors separate from the actual gear retract mechanism. Okay, let's delve into the programming. So let's enter the sequencer menu. Now, starting from the top, the first two parameters, you'll notice the top one says switch position and it currently shows down. And then just below that is a switch channel. So this switch channel here, we can actually go in here and change it. So I could make it 11, 12. So basically you select the channel you want to use that your radio is set to operate your landing gear basically. So I've set mine to use channel 10 for this example, and all you need to do in the transmitter is set just very standard plus and minus 100% travel on that channel. So my switch is just toggling between plus 100% or negative 100% travel. So if I flick the switch, you'll notice the screen now displays up, in other words gear up, and gear down. So that's fairly straightforward. Very easy to program. Now, the third option, gear up, output off. So this is what I was talking about, this nose wheel steering option. where we can lock the servo to a particular position. And all you need to do here is tell the sequencer what output we're using. So not what channel, but what output on the Mercury. So this particular steering servo is using the output labeled I for India. And all you need to do, again, is select this option and scroll through all the options. So you'll have, for the Mercury, because there's 16 ports, and they're all alphabetically coded. So port I is the one that I'm using for the steering servo, or for the nose wheel steering. And to actually program it, what you need to do is actually hold the wheel where you want it to lock. So for instance, if we need an offset, obviously if you want it straight ahead, you can just leave it like that. So you got to enter the programming for this. So you notice the little dot on the left hand side's gone solid. So we still have control of the steering. But say we wanted an offset, and I'll put an offset in so we can see when it's actually locked. So say we needed an offset to the left for the gear. So we want the wheel to go to the left slightly before it retracts into our wheel well. You basically hold it like that and then select it again, and now that's actually set. So when we throw the actual gear lever or gear switch, and I'll just do it there, you'll notice the servo's now moved to that slightly offset left position. If I set my landing gear switch to the gear deployed position, let's see what happens. Wait a few seconds because there's a delay, inherent delay that's been set. The default I think is 5 seconds, but we can change that later. And you'll notice now the steering servo, or the actual wheel, has gone back to its straight ahead position. And if I move my rudder stick, I've got control, and same goes for the gyro. I've got gyro control. And just to show you how it locks out the gyro as well, it's not just the actual rudder input, but if I keep moving the gyro left and right, and let's retract our retracts, see what happens. And I can keep moving the gyro, but the nose wheel's now locked to our pre-programmed position. Again, you might be flying around, ready to land. Let's deploy the landing gear. Let's wait a couple of seconds, and you'll notice once the servo returns back to its normal position, we've got normal control with the gyro and also with our actual rudder stick. So that's an extremely handy feature to have in the actual sequencer programming options. Okay, let's move down to the next option, which is the function. So here we can select a direct sequencer if we want to program up a particular sequencer. So within the Mercury, if I select that, we can scroll through sequencer number 1, 2, 3, and 4, and we can set these up manually. So to do that, you go down to the next option, which is manual setup, and you're presented with 2 graphs. Now, people doing servo matching and the likes on these units are probably familiar with these sort of displays. So the top display is basically the sequencer running in one direction, and then the bottom displays for the sequencer running back in the previous direction. So you can go ahead and manipulate these dots on the screen. So you've got basically 4 positions you can program. So you can adjust the time as well as the percentage of travel for the sequencer. So you basically got 8 points along a graph. So 4 in one direction, 4 in the other. And I won't bother going through these, but they're fairly easy to play around with. And like I said, you can adjust the time, so you can, stretch out the length that the sequencer operates between the 2 dots or across the whole time frame. It's fairly easy to play around with, but I actually suggest you don't actually enter it via the manual method. I'd use it for fine-tuning a sequencer, but initially I suggest you go straight to the setup assistant and set up the basic sequencer function using the setup assistant, only because it's a lot easier. And like I said, you can come back to these sequencers and fine-tune them. So we'll do that. We'll use the setup assistant and have a look at how that operates. Okay, so remember, we've got a gear servo here. We've got our front door servo, or our nose door, And then we've got two rear doors, we've got a left and a right. Let's have a look at what the setup assistant asks us. Okay, it's got a mode here. So we've got three modes to operate from. So what I'll do is I'll explain the modes later when we set up the full sequencer function, only because it's easier to do it at that point. So just be aware there's three modes. And the first question that the sequencer really asks us, apart from the mode, is how many rear doors do we have? So it's got an option of controlling one set of tricycle undercarriage. Could be a bicycle, I suppose, but yeah, typically with the tricycle you have a nose gear and you have basically two more gears under your main wing, and you may or may not have doors associated with that landing gear. So what it's doing here is asking us, do we have any rear doors? And we'll just say no for the first example. We'll come back to it later and we can add some doors to the rear gear. Now, here's that pause I was talking about. So there's a door gear pause here. So basically this pause allows you to adjust the time delay between when the gear retracts as to when the door closes. So for instance, if we look at the nose door, we can play around with this delay, and I'll play around with it a bit later, but for now I'll just set it to a more reasonable value. Instead of 5 seconds, because that's a bit too long, I might just set it for, say, 2 seconds. And you can come back to these values and change them later whenever you want to after you've programmed everything up. It's very easy to do. So let's set that for 2 seconds for now. Okay, moving on. Let's go to the next screen. So this is where it gets really, really easy to program. So first of all, it's asking us to connect gear to output D, D for Delta. So that's telling us to connect the gear retract. So for instance, in this case, this particular servo, and it's asking us to basically set the position we want for gear down. So remember, this would be controlling a valve, usually if it's an air system, or if you've got, say, some electron retracts, it'll just be, you know, like a plus minus 100% type setup. However, since I've got a servo here, let's have a bit of a fiddle. So let's enter this parameter, and what it's done here is once I've selected it, you'll notice the little dot's gone to a solid dot. It's actually pushed the servo out to the minus 100% position. So this is gear down, but I want this servo pointing down to simulate gear down. So let's change that. So hold down my button on my power switch, and it'll start off slowly, but then it'll ramp up in speed. So let's keep going. I want the little pointer pointing roughly vertically down. There we go, probably a bit too much. So it's around about 150% for this particular example. Make it 150, I don't know, let's make it 150. Oops, there you go. So this will be indicating gear down. So whenever you see this servo pointing down, that's indicating our gear down position. Now, let's move on to the next screen. So basically now, same servo. So this is a servo that's connected to output D. It's now telling us what value do we want for gear up. So this is where you'd set your gear up percentage, whether it's controlling a air valve or an electron gear controller. So let's select, now at the moment plus 100's there, but let's make the indicator point horizontally to the left. So that'll be our gear up position. So this is only really to give us a visual cue as to what the gear channel is doing. So remember, if you've got, you know, like an air valve, you really probably just have plus and minus 100% programmed in here or something similar. Now that sets up the gear servo, or the actual landing gear output signal, if you like. Let's move on to next. So now it's asking us for the front door. So this is our gear doors. So it's asking us for a position, so let's select it. At the moment it's at 0%, so 0% is roughly horizontal on the indicator there. So if I think I need to go the negative direction, I'm programming the door open position. So this servo is going to tell us when the door's open. So if we put in, I don't know, about 120% travel, it's roughly correct. That'll indicate door open. So later on when I flick the switch, we'll know the door's open by having the servo move to that position. Okay, let's go to next. And now it's going to ask us for the door close. So when we select the value, it actually slowly moves it to that particular position. So it makes it easy to program. And we'll just leave it on 0% because I'm happy with the horizontal indication. So with the servos in the horizontal position, that indicates a door close condition and also a gear up condition. And let's go to next. And what it does, the assistant runs through and it now says it's completed. So remember, we're just programming a gear function, so a gear deployment function. So this servo is indicating whether our gear's up or down. We've got one door, we've just got a nose wheel door, and we've also got a nose wheel. So at the moment, the nose wheel's steerable. It's controlled by the gyro as well. We're happy with that. The door's open, nose gear's down. Now don't forget, this gear signal is also controlling our rear gear as well. It's just that we haven't bothered with separate servos because, again, that might just be operating a valve or just a signal for your electron retracts. So retracts are down. The front nose door is open because we've only got one door on this aircraft. Now let's take off. So we take off and I'm flying around. So let's have a look at the nose wheel. And you'll notice this will offset to the left. Remember, we programmed a little offset in. So it should immediately lock to the left. The gyro will stop controlling the nose wheel and then these will operate. So let's see what happens. So in theory, the gear should retract first, and after a delay of 2 seconds, the door should close. Let's try it. Let's flick the switch. And there we go. Now say for instance the door is too slow or too fast. All you need to do is basically go into the function option and select door F and then go into manual setup. Oops. So let's go to manual setup, and you'll notice the curves have changed slightly from when I showed you earlier. So this is the actual travel for the actual for the door, for the nose door basically. So you'll notice there's a delay of 1 second to the first spot. And as I move through these dots or spots, you'll notice the servo will react accordingly. And then there's another delay, and then another delay. So the total time is 4 seconds to get to that point. And then if we go in the other direction, it does the reverse basically because it's set up pretty much. I think there's a change of slight half a second time difference there. The sequence has been programmed automatically by the assistant. So you can change it. So if you find the door's too slow or you want to vary the rate as it's closing, you can do that through that little graph, through that manual setup. I won't bother showing you how to do it, but it's easy enough to do. So again, if you go through the setup assistant, that pretty much sets it up for 99% of the cases that you'd be using this function. So again, let's deploy the gear. The door opens. The gear extends, and now we've got control of our nose wheel. So you notice carefully, I'll just retract the gear. So gear's retracted, doors are closed. Watch this guy here. Watch that he goes back to the normal position where we've got control of the nose wheel only after the gear has been fully deployed. So door opens, gear deploys, and then a little bit later, we've got nose wheel control. So again, that feature where it locks out the nose wheel is really, really handy. Okay, so we've set up this plane, but now we're going to modify the aircraft. We're going to have some rear doors as well to add to the system. How do we do it? Well, all we need to do is go back into the setup assistant. And the beauty about this system is the setup assistant remembers everything it's been previously programmed to. So we can we'll just leave it on mode 1 for now, all we need to do is now add some doors. Now you may have one input that controls two doors, or you may have two individual doors that need individual servos to control. So that's up to you. In this example, we've got the two individual servos, so I've just selected two here for the gear doors. And let's set that. This allows us for the delay I mentioned before. We'll change that later to show you the impact on the whole setup. Let's go to next. Now you notice at the moment the output D, which is this servo here, the gear servo, it's set to plus 150% travel, which was the vertical down position, and it's saved that. It hasn't deleted it. So we can just leave that as it is and scroll through. The gear up position's been saved as well. So again, I can just show you that. That's the gear up. But we can just leave that as it is. We don't have to change it. And now it's asking us to connect the front door output to output E. So that's this particular servo. Again, it's still got the previously programmed parameters. So all we need to do is just bypass that, go to next. If I push the right buttons, that is. And now we move on to the rear doors. So you'll notice the display is actually talking about connecting the rear right door, which is this servo here, and connecting it. It wants it connected to output F. Now don't forget, we can change these outputs later after the assistant's programmed all this up. But for now, we'll just follow the standard request here. So output F, and I've already plugged this servo into output F. And it's telling us to basically program the door. Now let me change the direction. I think it's in the negative. Yeah, there we go. So we're going to program it for door open. So you'd adjust this servo to how far you want the door to open. So I don't know, let's make this one 120 as well. 117, 18. There we go, 120%. We go to next. And this is the closed position, so let's select that. And because it's at 0 and this servo lines up at 0% to the midpoint straight ahead, so I'm happy with that. We'll just leave that as it is. And then it's going to move to the left door, which is this servo here. And again, let's program the door open position. So I think this one's negative. No, positive. Went the wrong way. Let's also make this one about 120%. Very good. So that's going to be door open. And then it wants us to program the door closed position. So I'm happy with the 0%, so I'll just leave that as it is. Hit next. It deploys the gear and it says assistant is now completed. Alright, so in front of us we've got the gear deployed. So remember, this servo is showing us that gear's deployed because it's pointing down. And all the doors are open. So let's retract the gear. Let's see what happens. There you go. So you notice the nose wheel was offset because we've programmed that offset in, if you remember. And then after a slight delay, the doors then proceed to close. So now we've got all the doors closed. We're flying around. When I come in for land, let's deploy the landing gear. Doors open, gears deployed, and now the nose wheel is controllable again. Simple as that. Now, okay, so we've done this. We're happy with that. Works pretty well. Let's go through the cycle again. So in this particular example, the doors stay open while the gear's deployed. So at the moment we've got the gear's deployed, doors are open. Let's close it, or retract the gear I should say. Doors close. Let's now deploy the landing gear. Doors open, and they stay open. Okay, just keep that in mind. So let's go back into the setup assistant. I'm now going to change the mode. So this is what they call mode 1. So mode 1, the doors open, gears deployed, doors stay open. You then flick the switch, gears retracted, and then the doors close. Fairly straightforward. Let's go to mode 2. Let's see what happens when we select mode 2. So I've got to step through the assistant throughout the whole, all the steps again, but I don't have to change anything else because it remembers everything, which is really, really handy. So let's just step through next, next. Wait for it to come back with confirmation that it's happy. There we go, assistant completed. So let's operate the gear now. You'll notice the doors are closed here. So let's go through a full cycle and see what happens now. Okay, I'm going to basically flick my gear switch. So at the moment gear's down, so basically that servo's down. Let's see what happens when I retract the gear. So the rear door's open, the gear's retracted, and then the door's closed. Let's deploy the landing gear. All the doors open, gear deploys, and the rear doors close. So this is the mode 2. So the difference between mode 1 and mode 2, in mode 2, the rear gear doors will close after the gear is deployed. So they won't stay open. So on some aircraft you need that facility. A lot of aircraft you don't, but on some aircraft it's nice, especially on some scale aircraft, it's nice to have the doors closed where they need to be closed. So again, let's basically retract the gear. So gear's retracted, and all the doors close and they'll stay closed. And remember our nose wheel's offset, so that's still programmed in. Let's deploy the landing gear. All the gear doors open, gears deployed, and then the rear doors close. And then we've got steering again. Okay, that is mode 2. So let's have a look at mode 3. Back into the setup assistant, let's change it to mode 3. Next, next. It's pretty handy that it saves the value so I don't have to go through adjusting them all again. Okay, wait for the assistant to come back with a finished message. Okay, so remember in the last example the rear doors would close after the gears retracted? Well, you can probably see what's happened here is we've got the gear deployed and now the front nose door's closed as well. So that's a third option for some aircraft. So let's retract the gear. All the doors open, the gear retracts, then all the doors close. Fairly straightforward. Now let's basically deploy the landing gear. Doors open, gear deploys, and then all the doors close afterwards. So this is our third option. So our third option closes the gear doors with the landing gear deployed. So again, certain aircraft need that option, and it's nice to have that feature available. Okay, now I'll just go back to mode 1 because it takes a bit less time to go through the sequence. And one last thing I want to show you is the delay time. So let us go through the assistant, and I'll just run through a full cycle. So this is mode 1 where the gear doors stay open. So we retract the gear, doors close, and then let's deploy the gear. Now, I want you to pay a little bit of attention to the delays between when the gear's up, doors closing, and vice versa when we're deploying the landing gear. So let's retract it. Notice there's a bit of a delay. Doors close. And now let's deploy the landing gear. Okay, now let's go to a large delay so it's obvious to us. So back in the setup assistant, let's make this door gear pause delay, instead of 2 seconds, let's make it say 6 seconds. Six seconds should be good enough to show us the difference. Let's go through to next, and again we just need to step through all the options in the setup assistant, but we don't have to change anything. Okay, it says it's completed. Let's see what happens now. So currently the gear's deployed, all the doors are open, we've got steering. Let's flick our gear switch. We're going to retract the gear. Gear retracts. But you'll notice now there's a lot longer delay before the gear doors actually start to close. And now we're in the fully closed position, or gear fully retracted position. Let's now deploy the gear. And if you notice carefully, the delay on the deployment side is different to versus the gear up position. So again, let's go to gear up. And you'll notice there's a long delay here between the doors closing and the gear being shifted to the up position. So let's go in the reverse direction. So you notice in the reverse direction, the gears operate, the doors open first. And then there's not much delay. It knows, basically because the system knows that the doors are in the fully open position, it knows it can then deploy the gear. Easy as that. So the delay that we're adjusting really only affects it on the retract side when we're retracting it. So basically if I flick it now, the gear will instantaneously retract like it just did, but there's a long delay before the doors close. So adjusting that 2 seconds to 5 seconds adjusts that particular delay. Simple as that. Oh, and one other thing I'd like to mention is if you program the sequencer on say a 3-position switch, you can actually pause the sequence. So for instance, let's say open the doors, and then I've got my switch on a 3-position switch, my gear switch for this example. You notice the system's now paused, and I can actually reverse it as well. So it may be useful to some. If it's on a 2-position switch, obviously you can still reverse it at any point in time, just like that. So during mid-cycle, if you flick the switch back, it won't just hang up the sequencer, it'll just work in the reverse direction. So that's handy, for an aborted landing or something like that. But the pause function, maybe not as handy. Someone might have a use for it in some situation, maybe if you're troubleshooting. But I think that's about it. I think I've gone through all the options as far as I'm concerned. Any questions? Just post up a question on the YouTube channel, and I should be able to answer it for you. But like I said, for me, probably the biggest feature is being able to lock the nose wheel. So, if we drop the landing gear, we now have control, and locking the nose wheel when we retract the landing gear to a particular spot. And like I said, usually it might be just straight ahead, but there's the option of us, programming a particular servo position for it. That's a real handy, nice feature to have. Anyway, I think I've rambled on long enough. I hope you enjoyed the video, and I hope you got something out of it if you're setting up some landing gear in your aircraft and you're using one of these PowerBox units. Really handy. All right, thanks all. Thanks for watching.